In this video, we're going to talk about tests for organic functional groups, which you've gone over in all of the organic course. And therefore, we're going to do exam-style questions to help you revise all those and make sure you know them. With all of this, please do the questions and then get me to explain. So this is an active process. Now, the tests you need to know are the decolorization of bromine by alkenes, the creation of different coloured precipitates by aqueous silver nitrate with haloalkanes. Now remember, chlorine is a white precipitate, bromine is cream, and iodine is a yellow, and they all have differing solubilities in dilute and concentrated ammonia, but we'll go through that in one of the questions. And one that often is missed is phenol's weak acidity. So it has a acidity somewhere between 5 and 6, okay, and that's nice to know because carboxylic acids have a slightly lower pH and therefore stronger acidity, okay, and obviously strong acids are at the lowest part of the pH scale, 1, 2-ish, okay, so really good to know that phenols have that weak acidity, but of course they don't react with sodium carbonate. So carbonyl compounds, now that's really good by reaction with 2,4-DMP. Specifically ketones. So if you want to identify a ketone, it's really good to use 2,4-DMP. Aldehydes can be done with toluenes, okay, which is the next one. Also, primary and secondary alcohols and aldehydes by reaction with acidified dichromate, that orange to green colour. And lastly, carboxylic acids by reaction with a carbonate or sodium carbonate usually. Now let's go on to our first question, which is an aromatic-based question. So we're going to do qualitative tests, which are lab-based tests, on an aromatic compound. So it's got benzene in it. And we've got all these different tests and observations. So we know toluene, silver mirror, so that should indicate we think we've got an aldehyde. 2,4-DMP confirms it is an aldehyde or a ketone. Then we've got the sodium carbonate, no reaction at all. Well, what does sodium carbonate not react with? Well, sodium carbonate doesn't react with phenols. Oh, it's got an acidity of 5. Well, that's roughly about where phenol is. So it says determine the functional groups in the compound, explain your reasoning. So let's put it to the side. Okay, and then let's have a look at phenol to start off with. So phenol is aromatic and it's weakly acidic. So that's a good starting point, and that comes from our acidity, which we've highlighted in the corner. We then go to our sodium carbonate. You can see our sodium carbonate's gone orange there, there's no reaction. Okay, phenol also doesn't react with sodium carbonate, and we now know as well, because there's no reaction with sodium carbonate, it's not a carboxylic acid, because carboxylic acids react with carbonates to produce bubbles. Now our next section is 2,4-DMPH or 2,4-DMP. Okay, it has a carbonyl. So we know it is an aldehyde or a ketone. Notice I've put 2,4-DMPH here, 2,4-DMP there. You can write it in either way, it doesn't matter. So we know we've got an aldehyde or a ketone. We know we've got phenol from the first two tests. Okay, now let's look at the toluene. The toluene says it must be an aldehyde because of this silver mirror observation. Okay, so we've got some clues here. So our clues are we've got an aldehyde. Okay, we definitely have a carbonyl, which then backs up the fact we've got an aldehyde. And we think we've got a phenol because of these 2 points here. Now, if we've got a phenol and an aldehyde, okay, we can then look at this and we can draw out a molecule. So there's a phenol. Okay, let's not forget that. Okay, and then we know we've got an aldehyde. So let's stick an aldehyde on. So if you're going to do it properly, OH is 2 or 4 directing, so we can put it in position 2 or 4. Let's put it in 4. Okay, and let's make it into an aldehyde. Now there are many different versions of this. Okay, for example, we don't know how big the molecule is. We haven't been given the molecular mass. One adaptation of this entire thing would be to say, here's a molecular mass, then work it out. But we haven't given you a molecular mass here, but be aware, if we give you a molecular mass or an empirical formula, you'd have to give it exactly the right structure, whereas here we can give any structure that has phenol and has an aldehyde. So this would be correct. So let's go back over the tests that we need to know and which ones we've done. So if you look here, we did phenols, okay, and the fact they don't react with carbonate and are weakly acidic. We did the 2,4-DNP reaction, Tollens reagent for aldehydes, and then we eliminated the carboxylic acids because there was no reaction with a carbonate. So let's go on to our next style of exam question, and this is where structures are given. So here are two structures, okay, and you have to confirm the presence of the functional groups in A and B. So you have to give some observations, give some chemical tests, and confirm what the functional groups are. So let's get rid of B and just look at A, and then we've got a haloalkane and we've got a primary alcohol. Notice there's a carbon there, it's not directly connected to the benzene and therefore it's primary alcohol. What will they react with? Well, primary alcohol can be made into an aldehyde or a carboxylic acid, and it can be done with acidified dichromate or sulfuric acid and potassium dichromate. And the reaction going from orange to green, and there's your reactants and there's your observations. So we've done that one and moved that across. The next thing is the haloalkane. Haloalkanes react with aqueous silver nitrate and ethanol. And let's go through what they produce. The bromine will produce a cream precipitate, and then if we add concentrated ammonia, it will dissolve and disappear. Let's move that across as well. So we have our first one done. Let's go to our next one. We've got a haloalkane again, but this time it's chlorine. And this time the OH is connected to the benzene. So this is phenol. Okay, so we've got a phenol group and a haloalkane. So our haloalkane is going to be the same reaction as we have over here, but this time it is chlorine. So it's going to be a white precipitate which dissolves and disappears in dilute ammonia. Okay, now we need a reaction for the phenol. So the phenol, okay, reacts with bromine. So it will react with bromine and decolorizes. Notice I start with the orange and then go to the white to try and show that. Now, that will create, usually if it's just phenol, a tribromo compound. Okay, but if it reacted with this one, you just put one bromine there because it reacts in the positions 2, 4, and 6, and 6 is already full, and 4 is already full, so it would just put a bromine there. But it would decolorize. So we've got all the reactions to identify the phenol, the haloalkanes, and the primary alcohol. Let's put it into a nice table. So here you have, on this side, the bromine, the cream precipitate, concentrated ammonia, and the primary alcohol, orange to green. And on the other side, you have got, again, the haloalkanes, this time a chlorines going to a white precipitate and dissolving in dilute ammonia. And then the phenol reaction with bromine, which decolorizes. And that's all you'd need to get the different functional groups that are in these two molecules. Now, let's now look at which tests we've used so far. So we've now done most of them. We just haven't done our alkenes reaction with bromine or looked at a secondary alcohol. Now, we have, however, looked at the primary alcohols turning into aldehydes, okay, and carboxylic acids, and we have now looked at the haloalkanes. Let's go on to our final question. In this exam style question, we are going to distinguish between the different compounds given using chemical tests and their observations. Let's move this to the side, okay, and I'll show you this table. Now, in this table, you can see that I've listed most of the reactions that can happen, okay, and I'm just going to tick to see which ones will react with whatever I've got down here. So I've got a carboxylic acid here. It will react with sodium carbonate and produce bubbles for A. The next one is an alkene. Now the alkene will react with bromine. And the primary alcohol can be oxidized. And if it's oxidized, the primary alcohol can be made to create an aldehyde. That aldehyde can be tested with 2,4-DNP, or it can also be tested with Tollens. And as you can see, all those reactions can happen. We'll decide at the end which ones we distinguish with, but for now, we are just ticking which ones we can do. Now for C. C is a secondary alcohol. Okay, so it can be oxidized using H plus and Cr2O7 2- to a ketone. Next one, our ketone. Now our ketone, this is an exam tip here, if you ever see a ketone you want to identify it, just go straight to 2,4-DNP. Right, now let's move this table down to the bottom, and now let's see how would we write out the answer to the question to show how we could distinguish. Well, we know full well that the first one, the carboxylic acid, reacts with sodium carbonate and creates bubbles. And that's different to everybody else, so that's fine. The next one is the alkene and the primary alcohol. Well, the alkene can be identified by bromine, okay, but if I want to identify the primary alcohol way, I could use acidified potassium dichromate, distill it to the aldehyde, and then add toluenes to get a silver mirror. Okay, now if the question said just to distinguish, you wouldn't need to put this part 2. Okay, if it asked it, but if it said you identify each functional group, you would have to do both. Does that make sense? I hope so. Okay, so if we go for the third one, that's a secondary alcohol, and if you add acidified potassium dichromate, it will oxidize to the ketone. And so basically, it will go orange to green, and if we don't have to do this second test, we can use bromine for this. That means we can use acidified potassium dichromate for this. Okay, again, depends on what we're being asked. If you just asked to distinguish, that works. And then for D, we have a ketone, and you add 2,4-DMP, and you'll get an orange precipitate. Remember, we're only being asked to use qualitative tests or to use chemical tests to determine the differences and distinguish them. This distinguishes. If you were asked to identify them, then you'd have to compare the melting point of the 2,4-DMP derivative to identify it, for example. You'd have to put a bit more detail in. Now that is an exam style question and worth quite a lot of marks in the exam, usually about 6. Now let's look at all of your different tests that you're meant to know. And by now, with the 3 examples that I've shown you, you can see everything has been covered.